this first question on this year's paper. Yep. Two parts to it. One's an indefinite integral you've got to solve, and one's a definite integral. Yep. So if you can do find the indefinite integral, then you should all know how to put the limits in and get the answer on the second one. Okay, but it's about what method to use here. Yeah, am I right? So if we take a look at this first one here, y is equal to the integral of x brackets x squared plus 2 raised to the power 4 dx. And that's about what method you use. Yeah? All agreed on that. Yeah? Now what you've got here is a function of x multiplied by another function of x. Yeah. And that is raised to a power. What we need to use is algebraic substitution. Do you remember that? Yeah. Because we've got a situation in here where we've got a function raised to a power. Yeah. So we let u equal the bit in brackets. Then we need to differentiate that. Remember differentiation? So what's the differential of x squared? What do we do? Now that's integrating. Multiply by the power and take 1 off the index for differentiation. 2x, and the constants disappear. Yeah? And then we rearrange that to say for dx. So we have to rearrange that for dx. So dx comes up here, 2x goes down the bottom. Yeah? Okay? There's a step in here we could have put in. Just let me do this. If we let u equal x squared, then y is equal to the integral of 3x u to the 4 dx. Okay, so what we can do now is say this integral, the integral we're looking for, 3x x squared plus 2 dx is equal to the integral of 3x u to the 4, right? And now we want to replace dx with du by 2x. So we've got rid of the dx. That's the whole aim of all that, as the dx has gone. Now what can you see from now? What normally do we do with constants? Take them outside. So we got a 3 and we got a divide by 2. We got a half. So we can bring 3 over 2 outside the integral. Yeah. Is there anything else you can see from that we could do? What can we do with the x's? Cancel them out. Yeah? The whole purpose of this method is that we end up with the x's cancelled out, and we have that in terms of du instead of dx. Yep. So now we integrate. How do we integrate u to the 4? Someone said it earlier, for differentiation. No, not quite. We add 1 to the index, so that's 3 over 2. You've got to keep that, right? Brackets, u to the 5, add 1 to the index, and divide by the new index. Yeah. One more thing to add on there. Plus c, constant of integration. Yep. And then, once we've done that, we got 3 over 2 times 1 over 5. So we can have this as 3 over 10. Yeah. And then we just place u with what we called u in the first place, x squared plus 2 raised to the power 5 plus c. That's the answer. Use an algebraic substitution. So between now and your exam, look back at algebraic substitution and practice it. Look for the examples in the Bird book on algebraic substitutions and practice them. Recognise is about recognising when algebraic substitution is needed. It's also needed in the second question, where you'll let u equal 0.2x minus 0.5 and go through a very similar process. Like I say, I haven't got time to go through every part of this exam paper, but I'm trying to show you what the different things are that are in it. Yeah? And there are plenty of examples in the Bird book of doing integration by algebraic substitution. Right? If you ended up with 3 over 2 times u x squared plus 2 to the 5 over 5, that is the same answer. Okay? So that simplification and making that 3 over 10 really doesn't make any difference. Alright? the final answer for B is 38.75. Question 2. Question 2. Now this question is the question that involved the formula, the integration by parts formula. So this was the question that had some contention about it. Okay? Yeah. I'm going to take a look with you at A. Yeah. Again, because part B is you using the indefinite integral you determined in part A to add the limits and get a final solution, which I'll give you the final answer to, so you can see if you can work to that. But I'm going to go through the first part because that's the nitty-gritty part, yeah? The second part is just putting in the boundary conditions. So if you've got the first part right, then that's fairly easy, yeah? Alright, you agree with me on that then? Yeah? So what we've got in this question is we've got y is equal to the integral of 2x squared e to the x dx. Yeah? Here we need to use integration by parts. So that's this formula that we had the issue with. So you go to the formula sheet. It's that the one at the bottom of the table there. The integral of u dv is equal to uv minus the integral of v times du. Yeah? And this is like a function times a function thing, in a little bit of a similar way to the differentiation. Function times a function. Alright? What we have to do here, the method here, is to, first of all, we let u equal 2x squared. And then we integrate. There are some cases where you need to let the other side equal u. The ln function, for instance. But it's a judgment call, and you kind of need to. There's no definite way. If you get to a point where you can't make the idea of this process is to make this differential here of v one that you can solve from the table. Yep, because you haven't got anything like that in the table, but you're trying to make that differential one you can solve. Alright? So du by dx, we multiply by 2 and take one off the index. And then we rearrange for du. So we say du is equal to 4x dx. So that's that half. And then we say we let dv by dx equal, let dv equal the other half, which is e to the x. Yeah. Then we integrate both sides of that. So if we integrate dv, we end up with v. And if we integrate e to the x, we end up with e to the x. That's that special one where there is no difference. Right? So that's, I've integrated, what I've effectively done there is integrated both sides of that. Yeah? I've now got a value for u, a value for du, a value for v. Yeah? And I put them into parts formula. So what I do is I say this. The integral we're looking for, 2x squared e to the x, is equal to, and then I fill in the parts of the parts formula. So we want u, which we said is 2x squared. I do recommend at the moment you put each of these terms in brackets, times v, e to the x, minus the integral of v, e to the x, times du 4x dx. Alright? And then there's some simplification that can be done. So we can say it's equal to 2x squared e to the x minus the integral, and we can, and hang on, the 4 that is a constant can come outside, e to the x dx. Now, at the moment, we still can't solve this. There's not a version of that in the table. So we've got to apply parts to this again. Yep. So we let u equal x du by dx is equal to, we integrate x on its own, what do we end up with? 1. Yeah. Therefore, du is equal to dx. And over this side, let dv equals e to the x. Therefore, v is equal to e to the x. Yeah. We then put those results into the by parts formula. So the integral of got something wrong up there. That should have an x in front of that, shouldn't it? Have a look here. That x, there's an x in there. Took the 4 outside, but haven't taken the x outside. Sorry about that. Alright. The integral of x e to the x dx is equal to, and again now we put these into the parts formula. So u No, because you've chosen u to be equal to this x, yeah, and dv equal e to the x. Alright? So now we're putting these into the parts form. So u is x, v is e to the x, minus the integral of v e to the x du, which is equal to dx. Checking and make sure I'm doing this right, yeah. Okay. Now what we got to do is bring these results together. So here's our first result. We got to write that now for that bit on the end there. Bit of a ball like this question, isn't it? So the integral of 2x squared e to the x dx is equal to, this comes from the first answer, 2x squared times e to the x, right, minus 4 x e to the x, and the integral of e to the x is close brackets. Right? And then we can simplify some of that. So we got 2x squared e to the x minus 4x e to the x plus, where have I got a plus from? Oh yeah, you got minus 4 times minus e to the x is plus 4 e to the x plus c. Okay, and I'll take your answer in that form. Alright, it will further simplify to e to the x 2x squared minus 4x plus 4, all plus c. And all I've done there is taken these 1, 2, 3 e to the x's outside of power brackets. Alright? But if you don't do that bit, that you won't lose a mark. And then the second half of the question is you using either of those two results to put the limits in and get a final answer, which in this question is 1.437. 1.437, Elliot. All right. So that's the first two questions. One of them's by algebraic substitution. The other one is by parts. Yep. Question 3. Electrostatic potential. Electrostatic potential. What method What method? Yes, algebraic substitution. Yep. So this question is the algebraic substitution we done for question 1. So I'm not going to go through the whole thing in detail. It also involves you though using a power for the square root and so on. Yep. So we got this integral between 12 and 1 of r over the square root of r squared plus 225 dr. Yep, and you're being asked to evaluate that. You're going to do it by substitution, i.e. let u equal r squared plus 225. No, you don't do that. Because the square root is a function, that makes it a function inside a function, doesn't it? Yeah? So what we're now looking at is, this is what we're now looking at, between 12 and 1 of r over u over the square root of u dr. Yep. And then we can write that as integral between 12 and 1 of r over u to the half dr. We then have to integrate u so du by dr what happens to the constant when we integrate? Differentiate, sorry, disappears. The 2 comes down, take 1 off the index. Differentiating, yeah. Therefore, dr is equal to du by 2r. It's 3 marks for getting that far. Alright? So, what we can now do is say VR is equal to the integral between 12 and 1 of r over u to the half times, and replace dr with du by 2r. All this process is to get rid of that r on the top. Yeah. What happens now? The r's cancel. Yep. The other r's cancel. What else can we do? Yeah. Effectively, we're bringing half out. Just be careful, right? Well, you could write, Elliot, you could write that bit as du times a half, couldn't you? Yeah. All right. So that half comes outside. That equals a half the integral between 12 and 1 of 1 over u to the half du. So all that process has got it in terms of du and cancelled that r out of there. Yeah? Now how can I rewrite that so I can integrate it? Yep. What do I have to do that as well though if I take it to the top? So that's a half integral 12 and 1 of u to the minus a half du. Yep. Now I can integrate. So that's going to equal a half times process of integration. I've got to add 1 to that, so that'll make that a half. And divide by the new index. Yep. And if we divide by a half, that's the same as multiplying by 2, isn't it? Yeah. So that's 2 u to the half. Right. And what happens there? Cancel, cancel. Boys? 2 there and 2 there cancel. See that? We should have our limits in here as well, shouldn't we? Equals u to the half between 12 and 1. And then we simply put back in I'm not going to bother about calculating that, but I will tell you what the answer is. It's 4.176 volts. All right? Time dictated that I couldn't come up with another applied question, so guess what you got? I'm not going to spell it out any more than that. All right? Happy with that question now? Yeah. Question 4. Maclaurin series. Determine the first 4 non-zero terms of power series for the function 2 sine t. Yep. Two sine t. So what it is remember the Maclaurin series is around the point where t is equal to 0, or if we're working with x is equal to 0. Right, so we need to calculate what the value of that function is when t is equal to 0. Sine of 0 is Sure? So that's 0. This is the nth differential of x, or function of x, and that's the value of that at 0. Right? So that's the first term, nothing. First differential, so differentiate 2 sine t, we get two cos t. 2 times the cosine of t is, when t is 0, well, the cosine of t is 0 is 1, so that must be 2. Yeah. F double dash x 2 put the minus in front. Minus 2 sine t. Sine t is nothing, so that's 0. F triple dash minus 2 cos t. So the answer will be minus 2. Fourth differential, back to 2 sine t, which is nothing. Okay, we all know that then goes 2, none, minus 2, and so on. And we're being asked for the first 4 non-zero terms. 1, 2, 3, 4. Did I ask for the first 4 or first 3 non-zero terms? First 4 non-zero terms. Alright? So we got 2 times the first differential, minus 2 times the third. That'll be 2 times the fifth, and minus 2 times the 7th differential. If you then look at your formula for the Maclaurin series, it says that function of x, function which that's our 2 sine t, is approximately equal to so what we can get from that is 2 times sine t is approximately equal to no constant term. Yeah, we got 2 times the first differential minus 2 times the third over 3 factorial, because the third differential is minus 2, yeah, plus 2 times x to the 5 over 5 factorial minus 2x to the 7 over 7 factorial. Okay, if you get a sine function, what would happen? Looking at this list, you've got a sine function to start with. Sorry, what if you start off with a cosine function? If that was 2 cosine t instead of 2 sine t, what would happen? That would be 2, that would be nothing. Yeah, you'd be using, instead of using the odd differentials only, you'd be using the even differentials only. Yeah, it's only if you had a function with both cosine and sine in it, you would end up with constants in all the terms. Remember, this is an estimation technique for that function. Okay? what you're then being asked to do is integrate that, right? And then, lastly, being asked to integrate that to get the exact answer to the problem. So that's an estimate. And you're then being asked to integrate this function. Okay? What I'm going to do is go through a couple of the terms, okay? Because in the end, they all follow a pattern. So what we're saying is that the integral of 2 sine t is approximately equal to the integral of 2x minus 2x cubed over 3 factorial plus 2x to the 5 over 5 factorial minus 2x to the 7 over the 7 factorial. Yep. And we're doing this between, pi and 0. And this should be not right now. I can't. No. Now I'll put x instead of t. Right. So when we integrate, so to integrate these, we just integrate, because they're plus or minus, we just integrate each part in turn, don't we? So when integrate 2t, we end up with what's the index here? T to the what? 1. Add 1 to it and divide by the new index. So what do we end up with? No. Yeah, 2t squared, sorry, over 2. Yes, yes. So 2t squared over 2, what would we write? T squared. Yeah. Minus okay, integrate this, so we got to do, that's t to the 4, so that's 2t to the 4 over 3 factorial times 4. How could I better write that? What does factorial mean? What does 3 factorial mean? 1 times 2 times 3. So if I then multiply that by 4, that's actually 4 factorial. Alright? So again, you start to see a pattern, because this is going to be plus 2t. Hang on. That's 4, that is. 2t to the, add 1, 6. Over 5 factorial times 6, the 6 factorial. And then lastly, minus 2x to the 8 over 8 factorial. And that's all between pi and 0. Yeah? And I reckon you could put them limits in there now and calculate that answer. No, you'll get an estimated answer from Maclaurin series in part B, which is 3.95. Yep. Yeah, and then in part C, you're being asked to use the normal table to integrate 2 sine t between pi and 0. If we integrate 2 sine t, what do we end up with? We already done it earlier on, didn't we? No, we differentiated it, sorry. If we integrate 2 sine t, what do we end up with? Look in your table. First of all, we can bring a constant outside. Yeah, I took a constant outside now. Alright, so we can put a 2 out there. So you end up with minus cos t between pi and 0. Put the values in, you get an answer 4. Which table are you looking at? You're looking at differentiation, I reckon. Yeah. Right. The answer, the exact answer to that problem is 4. Yeah. So the Maclaurin series estimate was 3.95. The exact answer is 4. Question 5. Determine the general solution of the equation x dy by dx is equal to 3 plus 5x to the 4. And then you've got a particular solution of a different differential equation. Okay? So, particular solution is that once you've solved it, you put in the details you've been given and get a general solution. Yeah, so effectively you find out what the constant of integration is and get a definite solution. Yep. Particular solution, sorry. So what I'm going to do is go through, because it's finding the general solution here that's the issue, essentially. What do you want? Well, what do you want me to do? Do A or B? Okay, I'll do A. What I'll do is I'll give you the final solution to B as well. Alright, we've got x dy by dx is equal to 3 plus 5x to the 4. Okay? We need to get rid of this x here, so we rearrange. We multiply, so we divide both sides by x. So we get dy by dx is equal to 3 plus 5x to the 4 over x. So that's multiplying by x. Yeah? Sorry. Divide by x. Yep. Can you see how we can simplify that at all? How else could we write this on this side? Nope. Not yet. We need to do this. We need to write it as 2 separate fractions. 3 over x plus 5x to the 4 over x. Yep. Now we can go 3 and get rid of that. Yep. So we've got dy by dx is equal to 3 over x plus 5x to the 3. We then integrate both sides. So if we integrate dy by dx, what do we end up with? Integrating is the opposite of differentiating, so if we integrate dy by dx, we end up with y. And that's equal to the integral of 3 over x plus 5x to the 3 dx. In your table, the integral of 3 over x is yep, and we can take, but what do we do with the constant on the top? That'll come in front, so that'll be 3 ln x. And integrate this. It's going to be plus, we've got to go x to the 4. That's got to be times 5 over 4 plus c. 5 marks for that. Now, part B is use the same method, so you've got to rearrange it, i.e. get the sine x and the 3 over the other side. Okay? Just so as you know, the indefinite, the general solution is a third cos x plus c. And then when you put the boundaries in, you get a particular solution of a third cos x plus a half, i.e. you should get c as being equal to a half when you put the boundary conditions in. General solution is a third times cos x plus c, and the final answer to the particular solution is a third cos x plus a half, with c in this particular case being a half. Alright? So are you happy with that question? Yeah? Right, the next question, second order differential. There's only one part to it because that's a little bit longer anyway, but determine a particular solution of the equation 6 d2y by dx squared plus 5dy by dx minus 6y equals 0. So that's a second order because that's got a second differential in it. Okay? And the first part of this question for 2 marks is determine the auxiliary equation. Which, if you don't get those 2 marks, I'm going to shoot you. Right? We've got 6 d2y by dx squared plus 5, yeah. You know what I mean. No, I haven't, no. If one of you dies within the next week or two for a gunshot wound, then I'm in a bit of trouble, aren't I? Yeah. Right. So, auxiliary equation is 6m squared 5m minus 6 equals 0. So all that squit in the bird book about D operator thingy and what have you, but I asked myself why you don't just go straight to that. Yeah, you would, because it's got to be a quadratic equation, remember. Yep. So you can choose whatever method you like to solve that quadratic equation, factorization, or use the formula. Okay. I'm not going to go through that now. I'm going to write down what I've got down here is by factorization. So it does factorize to 3m minus 2, 2m plus 3 is equal to 0. Yep. Therefore, m is equal to 2 over 3, or m is equal to minus 3 over 2. Yep. And you can go through that. If you can't use the quadratic formula by now, we're running out, aren't we? It's given to you in the back of the book. All right. If that was me, I think in an exam, instead of struggling to factorize, I'd use the formula. Yep. Okay. They are real and different. So if you're also being given in your formula book the form. So form is y is equal to a e to the k1 x plus b e to the k2 x. It's in that form. Yeah. Again, doing that tells me you know what you're doing. Therefore, the general solution is y is equal to a e to the 2/3 x plus b e to the minus 3 over 2 x. Yeah. Okay. Then what we've got is a situation where we have to put in, use the information you've been given in the question, which is that then x is equal to 0, y is equal to 5. Yeah. So 5 is equal to, no, e to the 0 is equal to any number at the power 0? 1. Yeah. So these two terms here are both 1. So 5 is equal to a plus b. Equation 1. Look, the question says boundary conditions when x is equal to 0, y is equal to 5. So we can write in y is equal to 5. If x is equal to 0, that is 2/3 of 0, which is 0. So e to the 0 is 1. I. Right? E to the 0 is 1. So we can say 5 is equal to a plus b. That's the first of two simultaneous equations. Yep. All right, boys? Then, also in the question,
you upload this to the tool thing?
What? I'll upload it to a page in the normal place. Yeah. What we need to do now is differentiate our general solution. So if we differentiate e to the 2 over 3x, what do we get? Differential of e to the ax is a times e to the ax. So we end up with 2/3 e to the 2/3 x, yeah, minus 3 over 2 e to the minus 3 over 2 x. And in the question, you're also told when x is 0, y is equal to 5, and dy by dx is equal to minus 1. So the differential, when x is 0, the differential is minus 1. So when x equals 0, dy by dx equals minus 1. So we can write minus 1 is equal to 2/3 e to the o minus 3 over 2 e to the o. All see that? And therefore e to the o is, oh, hang on 1 minute, we've got our a's and b's in there yet, haven't we? I got an a. Sorry, boys. Alright, and e to the o is equal to 1, yeah? So therefore we can write minus 1 is equal to 2/3 a minus 3 over 2 b. That is equation 2. Just remind myself what equation 1 was. Equation 1. Okay. So, what I've done is multiply equation 1 by 3 over 2. Yep. That gives me 10 over 3 for the other 2a hang on. 5 times 3 over 2. 15 over 2, isn't it? 10. Hang on. Right, question 7. Vertical motion of an object is represented by the differential equation ds by dt is equal to u minus gt. S is the height of the object at a time t seconds, and g is 9.81 meters per second squared. So they're kind of projectile question, right? With the first part being find a general solution to that ds by dt is equal to u minus gt, for which you'll get 3 marks. So we've got ds by dt is equal to u minus gt. Find a general solution. We've got to integrate both sides. So if we integrate ds by dt, we get integrate u, well, hang on, s is equal to the integral of u minus gt dt, integrate u, how could I put t in that and have it still just equal to u? T to the power of nothing, and that's still just u on its own. Yeah, because t, any number at the power of nothing is 1. Right, now go through the process of integrating that. We add 1 to the index and divide by the new index. We never bother to write t to the 1, and we don't need to put the 1 underneath, so the integral of a constant, the variable just comes back. If you look in your tables, you'll see that. Okay, and then integrating minus g times t. It's going to be, what's the index for this t? 1. So it's going to be g t squared over 2 plus c. 3 marks. Yeah. So that's part A. Part B says S is equal to 1.5 meters when t is equal to 0. Yep. So this is finding a particular solution. So 1.5 is equal to 0, the time, times 25, the initial velocity. Yeah. Minus 9.81 times 0 squared over 2 plus c. 1.5 equals 0 minus 0 plus c. Therefore, c is equal to 1.5. So that constant of integration is the initial height it starts from. See that? Yeah. Particular solution is S is equal to 25t minus 9.81 t squared over 2 plus 1.5. And if you think about this problem, it's going to start here at 1.5 meters. It's going to go up and up and up and up and up until it stops going up, and that's going to come down again until it hit the ground. Does that ring true for that equation you got there? Is that the right shape graph? Yeah? Parabola, it's a quadratic, isn't it? It's got a squared term. Negative squared term means it's an upside down parabola. Throw a ball up in the air. It's going to come down and hit the floor, yeah? And this is S distance. So that's time. And that's distance or height up and down. Yeah? Okay? Yeah? So that's part B. C, when t is equal to 1.8 seconds, distance travelled S is 25 times 1.8 plus 9.81. What? Times 1.8 squared over 2 plus 1.5. And that should get 30.6 meters. Now, I'm not going to go through the last bit step by step. I will give you the answer, right? But the last bit D, it says determine the time when the object hits the ground, right? Well, if you looked at my little graph that I drew, there's an understanding of what's going on here. The point when it hits the ground is when S is equal to 0, right? We've got a quadratic there. We're going to say that's equal to 0. Yep. So you'd writing that in standard form, you would have 9.8 minus 9.81 t squared over 2 plus 25t plus 1.5 is equal to nothing. Right? You then solve that quadratic equation, i.e. you find the roots. So you use a quadratic formula, you get a root over here somewhere, which is useless because it's negative time. This is the one we're looking for. So the positive root answer to that quadratic equation is the time when ball hits the ground again. Yep, you should get 5.16 seconds. .16 seconds. The throwaway negative value is minus 0.059 seconds. I'd kind of expect you to say that the negative time result is not valid, and you're choosing the positive one, and then say what it is. Yeah, yeah, but in this particular application, negative time is irrelevant. All right? You do indeed. Right, question 8. Current flowing I flowing in a series connected electrical circuit containing resistance R, inductance L, and capacitance C, represented by the differential equation as given. Okay, so it's a second order differential equation, and you're being asked to determine the auxiliary equation in terms of R, L, and C. Yep. So you're not initially given values for them, just want the auxiliary equation in terms of the variables R, L, and C. So we've got this d2 I by dt squared plus R over L di by dt plus 1 over LC is equal to nothing. What's the auxiliary equation for that? What's the auxiliary equation? What's the coefficient in front of the second differential? What number could we put in front of it and that'll still be the same? Coefficient in front of di by dt is? Agreed? No, that you're right in that quadratic that it's the auxiliary equation, aren't you? Yeah. But you did it. We did in the other one that we're going to go back to in a minute. Yeah. Okay. Happy or not? When that was numbers, you were quite confident. Yeah. Let's go back to the numbers one a minute. 6m squared, that was you who told me what it was earlier. 6m squared, 5m, minus 6y, down to minus 6. 5, yeah, r over L that is. So instead of 5 we got r over L. Instead of 6 we got no number, which is 1. Yeah? And instead of minus 6 we got 1 over LC.
So would it not become R over LN?
Yeah, that was the little bit of sound. So R over,
Oh, is that what I've written?
yeah, R over L.
Sorry. Yeah. We all make mistakes, don't we? Okay. Some more than others. 3 marks. Yeah. I don't know. Probably, Dan. I hope so. Right. So B, right, is that you're going to use the quadratic equation. So m is equal to minus b, so it's minus r over L, plus or minus the square root of minus r over L, yeah, we'll put the numbers in a minute, squared, minus 4 times 1 times 1 over LC, all over 2. Alright, then you put the given values in, so it's equal to minus 400 over 0.4 plus or minus the square root of minus 400 over 0.4 squared minus 4 times 1 times 1 over 0.4 times 10 times 10 to the minus 6. You do all of that, okay? I'm going to jump the gun and say m is equal to minus 500. There's only one solution. That bit in there comes to nothing. All of that, that's times 10 times 10 to the minus 6. It's the capacitor value, Mike. Yeah. 4 times 1 times L over C. Hang on, what I'll do, guys, is I'll move it over so I've got enough room and I'll write it in again. We've got equals plus or minus square root of minus 400 over 0.4 squared, yeah, minus 4 times 1 times 1 over 0.4 times 10 times 10 to the minus 6. Yeah, divided by 2, because A is 1. Yeah, all of that bit in that root equals 0. Yeah, and therefore this bit is minus 1,000, so minus 1,000 over 2, m is minus 500. Just trying to save some time, because you can use the quadratic formula hopefully. Therefore, general solution is that I is equal to AT plus B e to the minus 500t. 4 marks for getting to there. Because in your types of thing, real and the same is in the form of y equals ax plus b in brackets times e to the kx, k being the value of m. Yep. Okay. Part C, when t equals 0, I equals 0. Therefore, 0 is equal to none plus b times e to the 0. Do you agree? B is equal to nothing. Happy or not? Now, we've got to differentiate our general solution. So we've got to find the I by dt. we've got a function of t multiplied by another function of t. So we've got to use product rule. Let u equal at minus b. Let v equals e to the minus 500t. Du by dt equals, differentiate that, constant disappears, doesn't it? It's equal to a, because that becomes t to the 0, which is 1. Yeah, differentiating now. And dv by dt is equal to minus 500 comes outside, e to the minus 500t. If you look in your table of or formulae for differential calculus, yeah, product rule is that dy by dx is u times dv by dx plus v times du by dx. Therefore, dy by dt is equal to, we're looking for u, what did we call u? At minus b times minus 500 e to the minus 500t plus, and then we want v e to the minus 500t times du by dt, which is a. All right? We'll get that. And then in the question it says, when t equals nothing, di by dt equals 200. Therefore, 200 is equal to none minus b, yeah, t is nothing, times minus 500 e to the o, agreed, plus a times e to the o. Yep. Agreed? So this bit is worth minus 500b, and this bit is worth a. What was b equal to initially? Yep. Therefore, particular solution is I is equal to 200 t times e to the minus 500 t.
Through there after lunch.
Yeah, I'm staying in here all the time, yeah.